Here's another quadratic application, and I like this one because it really does force you to think about units and dimensions and things of that nature. So here we go. A garden that is 20 feet by 30 feet, and that's a rectangle garden, is to have a sidewalk border poured from 2 cubic yards of concrete. If the sidewalk will be 3 inches deep, what is the width of the sidewalk? Alright, so I think part of the battle is drawing the correct picture. And this one's not hard. Here we have our sidewalk, 20 feet by 30 feet. And we're going to pour a sidewalk around this garden. And the width of the sidewalk is going to be X feet, if we want to work with feet. Alright, so here's our sidewalk, and how wide is it going to be? Now we have a couple of approaches here. We could attempt to come up with the area or the volume of the sidewalk just by looking at this, or we could think about this, as I think I'll do. I'll think about this as the area of the sidewalk is the area of the outer rectangle minus the area of the inner rectangle. So, but looking at it, we're looking at area, and this really involves volume, doesn't it? Right. So let's think about how the volume is going to play out on this. We have 2 cubic yards, and it will be 3 inches deep, and everything else is measured in feet. So we have feet, yards, and inches. What are we going to use? Well, how about we compromise on feet? It's in between. So it is 3 inches deep. If I multiply by 1 foot over 12 inches, I get 1/4 of a foot deep. So we know how deep it is. What about 2 cubic yards? How much cubic feet is that? Well, 2 yards to the 3rd power. Oh, I didn't do that right, did I? Because it's 2 cubic yards, so I have 2 times 1 yard cubed. 1 yard is 3 feet, so that's 2 times 27 feet cubed. And 3 feet. 1 yard is 3 feet. I was getting ahead of myself here. 1 yard is 3 feet. 3 to the 3rd power is 27. So here I've got 27 times 2 is 54 cubic feet. So the concrete is 54 cubic feet. The depth of the sidewalk is 1/4 of a foot. Now, how are we going to use that stuff? And here's what I want you to consider. Now, I'm going to, I have to make some room, so let me erase the statement of the problem. And my approach, and you don't have to do it this way, but I think it makes a lot of sense. My approach is to dispense with the thickness, the depth of the sidewalk, and think of this problem only in terms of area. So here's something to consider. Volume is length times width times height. But if you look at length times width, what is length times width? That is area. So volume is area times height. All right. Now the volume of the concrete is 54 cubic feet. And the height of the sidewalk is 1/4 of a foot. 1/4 foot. So if we solve for the area of the sidewalk, we would be dividing 54 cubic feet by 1/4 of a foot. Cubic feet divided by feet will give you feet squared, or square feet. 54 divided by 1/4 is the same as multiplying by 4. So the area is actually 4 times this number. 216 square feet is the area. of the sidewalk. All right, not the total area, just the sidewalk. All right, so we have something to shoot for. This shaded area, I don't have to worry about the depth anymore, the 3-inch depth. It's just looking at area. Is 216 square feet. Now then, let's see if we can get that. The outer rectangle is, so the outer rectangle has what area? All right, well, it's going to be 30 plus 2x, because I'm adding x to both sides of 30. And the width is going to be 20 plus 2x, so 20 feet plus x on both sides, 20 plus 2x, and that's square feet. That's the area of the outer rectangle. Now the inner rectangle, which is the garden, is what? It's simply 30 feet by 20 feet, which is 600 square feet. So if I take this entire area, everything you see, and subtract off the inside 600 square feet, then it will equal to the area of the sidewalk, isn't it? So I need to take the outer rectangle